Hello everyone, I am Dr. Revathi, Associate Professor in Physics, Department of Freshman Engineering, Marri Laxman Reddy Institute of Technology and Management. Today we are going to learn about conditions of lasers, requisites of laser system and pumping mechanisms. So here we are going to learn what are the main conditions to get the lasing action and what are the requirements for the laser systems, and also what are the pumping mechanisms we are using for exciting the atoms. So in order to know the conditions for lasers, first of all what we need, there are two things we need to get the stimulated emission. First one is metastable state and second one is the population inversion. So this is the main condition for getting the stimulated emission. So for getting the stimulated emission we need population inversion. So to get the population inversion we need metastable state. So what is this metastable state? Before that we need to remember one small thing. That means here we already in previous classes we already learned about the two-level laser system, where E1 is the energy of the ground state and E2 is the energy of the excited state. So there are three quantum processes we already learned. Yeah. So here first process, all the atoms at thermal equilibrium, all the atoms are in ground state. So if you give sufficient energy, so what is going to happen? The atoms absorb this energy and they started to move to the excited state. Okay. So here the atom will stay in the excited state. That means higher energy state for a particular time period. The time period of that atom is 10 power minus 8 seconds. That means the lifetime of the excited state is 10 power minus 8 seconds. It's very small. So after 10 power minus 8 seconds, what is going to be happen? The atom will comes to the ground state by emitting photon energy spontaneously. This one we are going to call as spontaneous emission. But in our lasers, the main principle is the stimulated emission. In order to get the stimulated emission, we need population inversion. In order to get population inversion, the other thing we want is the metastable states. What are these metastable states? Means these metastable states are in between the ground state and the excited states. These metastable states are in between the ground state and the excited state. Here, in these metastable states, the atom will stay for the long time. That means the lifetime of the metastable state is 10 power minus 3 seconds. The lifetime of the metastable states is the 10 power minus 3 seconds. If you see here, this is level 1 and this is intermediate state and this is the excited state. For example, I will give here. So see here, this is E1 ground state and this is the excited state, and for example I am going to write some E3. So you see here, at first all the atoms are in the ground state. After giving some energy to the atoms in the ground state, they started to go to they are going to excited state. At first the atoms will absorb the energy and they move to the excited state, not the metastable state. After coming to the ground state, that means from excited state to ground state, they are going to stay in the metastable state. Here it will stay for the long time. The lifetime of the metastable states is 10 power minus 3 seconds. So here what is going to be happen? If the more time is there, more number of atoms are accumulated in this metastable state. That means we will get more, there is a probability of occurrence of the stimulated emission. If the stimulated emission is there, then we will get the more lasing action. So what are the metastable state means? The metastable state is the state in between the ground state and the excited state. Here the atoms will stay for the long time. That means the lifetime of the metastable state is 10 power minus 3 seconds, whereas the lifetime of the excited state is 10 power minus 8 seconds. So due to this more long lifetime, the atoms will have probability of having more number of atoms are having accumulated, and there is a more probability of getting the stimulated emission process, and we will get the amplified light. That means this amplified light means we are going to call as a laser light. Now coming to the population inversion. Here inversion, we are calling the population inversion. Generally, we will call population is the general. Okay, inversion is the reversible process. So, here if you see here, first of all, we are going to see with the two levels only, where even is the energy of the atoms in the number of atoms in the ground state. That means N1 is the number of atoms in ground state and the atoms energy is even, whereas N2 is the number of atoms in the excited state and their energy is E2. Here in general, the population means N1 is greater than N2. That means the number of atoms is higher in ground state when compared to the number of atoms in the excited state. So, here this is the at thermal equilibrium, the number of atoms in ground state is higher than the number of atoms in the excited state. This one we are going to call as a population. In order to get the stimulated emission process, we need population inversion. That means we need inversion. Inversion means simple. It means so the number of atoms are higher in excited state when compared to the number of atoms in the ground state. See this figure 2. So this figure 1 we are going to call as a population, and this figure 2 if you see, so the number of atoms are higher in the excited state when compared to the number of atoms in the ground state. That means the population inversion condition is N2 is greater than N1. That means N2 is greater than N1. So, if it is the case, then only we will have more lasing action. That means we will have the stimulated emission process. Okay. So, here stimulated emission process is going to associated with three main things. One is pumping. Sorry, this population inversion is going to associate with three main process. One is pumping, second one is amplification, and third one is stimulated emission. So, these three are the major factors that are associated with the population inversion. So, we will see. Here, earlier we see the two-level energy system. Now we can see these two are the three-level energy system, because while we are learning for the different types of lasers, we need to understand the 3 levels and 4 level energy level systems only. So here if you see, where E1 is the energy of the ground state and N1 is the number of atoms in the of the ground state, where here if you see this, when compared to even N2 and N3 are the higher energy levels. In the same way here also, N2 and N3 are the higher energy state. If you remember that the metastable state, we can call this N2 as a metastable state. We can call this N2 as a metastable state. Generally, so population means here if you see N1 greater than N2 greater than N3. But here the case, it is not the case. It is the reverse case. But here if you see, in metastable state only, more number of atoms are going to be accumulated. So that means due to the more longer lifetime, more number of atoms are accumulated and we have the more probability of having the stimulated emission. So one condition, that is stimulated emission. That means stimulated emission means here during the emission, the induced observed photon and the emitted photon, 2 photons here. Stimulated emission means we are going to get the 2 photons. We are going to get emission of 2 photons. That means these 2 photons are going to obey the 4 laser properties. One is directionality, second one is monochromaticity, third one is the coherence, and fourth one is the intensity or brightness. So here if you see that here stimulated emission, and next one is the amplification. Amplification, how we are getting amplification means here, so while emitting we are getting the 2 photon emission. So what is this 2 photon? One is the incident photon, second one is during in the excited state we are giving the external energy. So these incident photon and the external photon, they both will emit. These two photons will emit in same direction, having same wavelength and going to following the property of the coherence. So due to all these properties, the output of the light is having the high intensity. That means we are getting the lasing action. We are getting lasing action. Once more I will repeat it here. So here, while here in metastable state only, more number of atoms are going to accumulate. So from this state, the atoms are going to emit and they will comes to the ground state. While emitting, we are having two photons. These two photons, what are these two photons? One is the, if you see here, one is the induced absorbed, and that means incident photon, and second one is the whatever the photon we are giving in the photon energy we are giving in the excited state. These two photons are following the same direction, having the same wavelength, coherence and intensity and brightness. Due to this, what is going to be happen? We are getting the amplified laser light. Okay, we are talking about the stimulated emission and we are talking about the amplification. So if you are talking about the population inversion, what is population inversion? So more number of atoms are higher in the excited state when compared to the ground state. So that means before the stimulated emission and amplification process, what we need? Pumping. Pumping is the main and important thing for getting the population inversion. What is pumping means? So we need some energy source. So to move the atoms from ground level to the other different levels, either excited state or some other level. So here we pumping also plays an important role. So and another important thing is here we are saying the population inversion. That means, so if you see here, the state of the system in which population of higher energy is more than the lower energy state. So generally the state of the system having the number of atoms is higher in the ground level when compared to the number of atoms in the excited level. But here what is going to happen? The state of the system which is having the number of atoms higher in the excited state when compared to the number of atoms in the ground state. So this one we are going to call as a negative temperature state. Because this is the reversible process, inverse process. That's why we are calling this one also called as a negative temperature state, means population inversion state only. So here the energy distribution in different energy distribution of atoms is of the atoms. The energy distribution of the atoms is going to be followed using the Boltzmann distribution law. The number of atoms in different energy levels is going to be followed by the Boltzmann distribution principle. Here if you see, this is the if you see N1 is the number of atoms in the ground state, N2 is the number of atoms in the excited state, where E2 is the energy for the number of atoms in the excited state and E1 is the number of atoms in the ground state, where Kb is the Boltzmann constant. This is a constant value, and temperature. So what is going to be happen? This number of energies is going to be also vary depend upon the temperature. If we have lower temperature, more number of atoms are there in the ground state, where if you are increasing the temperature, more number of atoms are there in the higher energy state. So that's why here we are, for population inversion, we are getting the non-equilibrium state, whereas population we are getting the equilibrium state. So if you see here, we just simplified this equation, N1 by N2 equal to exponential of h nu by kt or kbt. If you see, E2 minus E1 equal to Eg, or that is equal to h nu. This is the difference between the two levels. This is E1 and this is E2. This difference we are going to call as h nu or Eg. This is the minimum energy we are giving to the atoms to excite from one's level to the another level. So this is the population inversion. What are the conditions to get the population inversion? There are some conditions to get the population inversion. What are those conditions? So there must be at least 2 energy levels. One energy level is not possible to get the population inversion. That's why definitely at least 2 energy levels are required to get the population inversion condition. And another important thing is we need some source to supply the energy. That means this source to supply the energy we are going to call as pumping. We are going to call as the pumping. Pumping means we are giving some different forms of energy. We are giving different forms of energy to excite the atom from ground level to the higher energy level. So this one we need. Definitely we need 2 energy levels. Another one is pumping we need. In the same way, here the atoms will excited. The atoms will rise to the higher level continuously. This is a continuous process. And next one is and metastable states also we need. Metastable states also we need. Without metastable states, there is no population inversion. If there is no population inversion, there is no lasing action. That means no stimulated emission is going to be occurred. So because for laser, stimulated emission is the main principle involved. So metastable states are the states that are in between the ground state and the excited state, and the lifetime is very high. That means 10 power minus 3 seconds. In this state, the atoms will stay for the longer time. And whereas for population inversion means here number of atoms are more in the excited state when compared to the number of atoms in the ground state. Okay. So in order to get the stimulated emission process, we need population inversion. If you need population inversion, we need the metastable state. And next, these are the main condition for getting the lasing action. So what are the requirements for the lasing system? For each and every laser system, there are some basic components. What are the basic components? There are major 3 basic components are there. They are, first one is active medium, second one is pumping source, and third one is the optical resonator. Whatever the laser we can take, these 3 are the important thing. Without this, we can't build the laser also. So what are those 3? So here energy source or pumping source. We can call as a pumping source also. Active medium and optical resonator. So see here. So this is the active medium. This is the energy source, and this one mirror M1 and this one mirror M2, and this is the output. This is the laser system. This is the general laser system. Whatever laser we are using, these are the 3 major components involved in that one. Okay, one by one we can see. So what is pumping? So pumping means energy source. Pumping means here energy source. So what is going to be happen here? So the atoms are in the ground state. So if you give some energy, what happens? The atoms absorb this energy. They started to move from E1 to E2. They started to move from E1 to E2. So that means here we are supplying some energy. This energy also we are supplying in different forms. I will talk this one later. Okay. So there are different forms of pumping mechanism are there. So based on these different forms, the atoms are absorbing this energy and they started to move from the ground state to the excited state. Okay. So this one we are going to call as either pumping or energy source. Okay. Which is one of the important thing for getting the population inversion also. And second one is active medium. Active, why we are calling this one as an active medium means here only we are getting the stimulated emission process. In order to get the stimulated emission process, we need population inversion. So here if you see, active medium is a medium in which population inversion takes place. That means this is the place where we are getting the population inversion. So population inversion is one of the important one for getting the lasing action. So after getting this population inversion, we are having the amplified laser light in this medium. So that's why this medium we are going to call as active medium. So in this place only we are getting the major principle. So we are going to call as an active medium. Here the medium means either solids, liquids and gases, because we have different types of lasers based on the solid laser, as liquid lasers and gases lasers. Okay. Next one is active centers. What is this active centers means? Okay, here in this active center, the atoms are raised to excited state. This means active center. If they are in excited state, if the atom is in excited state, then only we are getting the emission. That means the atom will comes to the ground state by emission. So that means here active center means, so we need pumping, and next one is we need population inversion. Okay, so in order to get the population inversion, we need the pumping. So where we are getting the excited state atoms, that means if the atoms are raised to excited state, that medium, that centers we are going to call as active centers. And the next one is optical resonator, because this optical resonator means it consists of two mirrors, M1 and M2. One is fully reflecting mirror and second one is the partially reflecting mirror. So these two mirrors are placed each other parallel. If you see here, this one is M1 and this one is M2. And we are getting the output from the partially transparent mirror. If you see here, laser beam. Okay. So our active medium is in between the M1 and M2. This M1 and M2 we are going to call as an optical resonator or optical cavity. So what is going to happen here? The atoms are moving to and fro, and they are going to, what happens? So if they are going to and fro, so what is going to happen? We are getting the maybe multiple. If one atom, so for one atom, we are getting the 2 photon energy. For 2 photons, we are getting the, for 2 atoms, sorry, for 1 atom, 2 photons. For 2 atoms, we are getting 4 photons. That means, so they are going to be multiplied. With these mirrors, they are going, that means the intensity. What is the purpose of the optical resonator? Means the intensity of the light signal is going to be strengthened. The intensity is going to be increased. So if the intensity is increased, so what is going to be happen? We are getting the, laser light, high coherent, and at the output we are getting the highly intense monochromatic coherent laser light through a non-reflecting portion of the mirror. See, I said one is fully reflecting mirror, another one is a partially reflecting. From this partially reflecting mirror only we are going to get the output of the laser. So what are the 3 major components of the laser system? Means one is the pumping source, that means pumping or energy source, and second one is the active media, and third one is the optical resonator or optical cavity. Here why we are calling out, here we are using the mirrors. So these mirrors are made up of the glasses. So that's why and also these are we are calling as one is the fully reflecting and another one is the partially. This reflection and transmittance and absorption, all these terms are related to the optical terms only. So we can call optical resonator, light only. Even here we are using the laser means light source only. Optical resonator. So pumping source means here it is used to excite the atom to the higher energy level. And another one is active media. In active media, we are going to get the population inversion. Whereas so optical resonator. In optical resonator, what is going to happen means, so we are getting the high intense and coherent laser beam out only. So so only high intense coherence. Coherence is also one of the important thing for the lasers. So these are the major components involved in the laser system. Whatever the laser we can use, these 3 components are present in these laser systems. So next one is pumping mechanisms. Okay, we talk now. So for population inversion, we need and pumping. So there are different types of pumping mechanisms we are using. So that means pumping means the atoms are going to move from the ground level to the excited level. So what are the different types of pumping sources? In what form we are giving the energy? That form is, one is the optical pumping, electrical discharge, inelastic collision, direct conversion and chemical pumping. If you see, it is general water pump. So what we are doing, if with the piston, if you push, what happens from the ground, we are getting the atom. Sorry, if you push with the piston, what happens? The water is coming from the ground and we are getting the water. That means we are giving some energy. So in the same way, pumping. So we are giving energy to go the atoms to excited state. So there are different types of pumping mechanisms are there. One is optical pumping, second one is the electrical discharge, and third one is inelastic collision, direct conversion and chemical pumping. So we will go with one by one. So here optical pumping, the term itself is indicating that means here we are using the flashlights, xenon flashlights. So that means here with the help of the light sources, what is going to happen? So this is the light source. Here source is different. The process is same. Process means the atom is going to move from the ground level to the excited level. So here optical pumping means, so here the name suggested light is used to get the population inversion. So that means here we are using the xenon flash lamps to excite the atom in ground level to the atom in the excited level. So the best examples are solid state laser. In solid state laser, we are using the optical pumping as an pumping mechanism. To excite the atoms, we are using the pumping mechanisms. Solid state laser, ruby laser, NdArc laser, this type lasers, they are using the optical pumping. And next one is electric discharge, where we are using this electric discharge. This electric discharge we are using in gas lasers. Gas lasers means helium neon laser. Helium neon. And second one is carbon dioxide, CO2. So these two type of gas lasers, we are going to use this type of pumping mechanism. So what is this electric discharge? So you see here we are using the high voltage electric discharge. High voltage electric discharge means the flow of electrons or electric charge or electric current is passed through the laser medium. Here laser medium is also called as an active medium. So here high voltage is going to give into the active medium. That means electric charge is going to pass through the active media. After passing this electric current to the active media, what is going to be happen? So after passing, so what happens? This electric field accelerates the electrons with very fast. This electric field, what is going to happen with this electric field? The electrons are going to accelerate very fast, and this electric field electrons are going to collide with the, where they are going to collide? They are going to collide with the gas atoms present in the active media. They are going to collide with the gas atoms present in the active media with this active media. So what is going to happen after collision? What is happening? So these atoms get energy and they started to move from ground state to higher energy state with this sufficient thermal energy. They started to move from the ground state to the higher energy state. Okay. So this one we are going to call as an electric discharge. Whereas in optical pumping, we are using the xenon flash lamp. Here we are using the high voltage electric discharge. That means either electric charge, electric current. So if you pass this electric current, So what is going to happen? The electric field, the electrons are accelerated very fast and they collide with the gas atoms. So what is happening after colliding? So what happens? The atoms get energy. They started to move from. So which energy they are getting? The atoms are getting the thermal energy, and they are started to move from the lower energy state to the higher energy state. This one we are going to call as an electric discharge. Okay. So the best example here is the gas lasers, helium neon. So next one is inelastic or atomic collision. What is this? This also comes under this gas lasers only. So what is this? Here this electric discharge is going to help for initial excitation only. For example, if you take two gas atoms, helium neon. Helium neon are two gaseous atoms. Okay. So with the help of the electric discharge, only helium atoms are moved from the lower energy state to higher energy state. What about neon? So that's why we are going with the inelastic or atomic collision. So what is this inelastic or atomic collision? I will explain. So if you see, let us take two gases. So X and Y. So X and Y. So we can take helium and neon. So what happens? So here one important thing is, so these two gaseous atoms, helium and neon, in excited state, I will draw. This is helium and this is neon. First, this is electric discharge. Through electric discharge, I will draw again clearly. So this is helium, this is also helium, and this is neon. So helium atoms in ground state. So through electric discharge, so what happens? They get sufficient energy. They started to move from the ground state to excited state. They are in excited state. So we can say this is X, this is Y. So X star means, if you see here, X star means here excited state. Okay. So here now neon atoms, and then this is also Y star, excited state, Y star, excited state. Okay. So here we need to remember that in order to have this type of elastic collision, there is one condition, that means both the gas atoms excited state energies have similar energies. Whereas helium energy excited state and neon excited state energy, they both have similar energies. Otherwise we couldn't get this inelastic collision. Okay. So with the help of the inelastic collision, what happens? So the atoms goes to the excited state. This is one atom. So X. So what happens? We need neon also go to the excited state. So how it is going to happen? So this excited helium atom is going to collide with the ground state neon atoms. The excited helium atom is going to collide with the ground state neon atoms. So what is going to happen? As a result, what is going to happen? The neon atoms get sufficient energy. They started to move from ground state to the excited state. That means with the help of the collision, only helium atom and neon atom, due to these collisions with atoms only, we are going to call as an atomic collision. With the help of the atomic collision, the second gas atoms also move from lower energy state to higher energy state. So that's why this one we are going to call as atomic collision. First one is optical pumping, second one is electric discharge, and third one is the inelastic or atomic collision. And next one is direct conversion. What is this direct conversion? This direct conversion we are using in the semiconductor diode lasers. Okay. So here with the help of the electrical energy. With the help of the electrical energy. So, if you apply the electrical energy to the direct band gap semiconductors. Semiconductors means you need to remember that here we have two types of charge carriers. One is electrons and second one is the holes. Okay. Here two types of charge carriers. In the same way we have two types of band gap. One is band gaps. One is direct band gap and direct band gap. Second one is indirect band gap. Just I will give very brief about this direct and indirect. Here, if you see, in direct band gap, this is the conduction band and this is the valence band. So, what is happening? The valence band maximum and the conduction band minimum are at the same positions, are at the same k values. K means wave vector values. So here, we don't need to give the extra energy. Only we will give only one energy. That energy we are going to call as a photon energy. That means here both the energy and momentum are conserved. Both the energy and momentum are going to be conserved. So, here we are having the less band gap values. The values are going to be less. Okay. Whereas in indirect band gap, I will explain again. So, here the maximum of the valence band and the minimum of the conduction band will have at same k values. K means here we are going to call as we are going to wave vector. So, and here both the momentum and energy is going to conserve. Here we are using only one energy. That energy we are going to call as a photon energy. So, and the values here for direct band gaps, the values are less when compared to the indirect band gap semiconductors. Whereas indirect band gap semiconductor, we don't have the same k values. So, here if you see here, this is valence band maximum, this is conduction band minimum, this is indirect band gap. So, here the valence band maximum and the conduction band minimum is not occur at the same k values, and in order to get the conservation of momentum, we need extra energy. That energy is phonon energy. Whereas for direct band gap semiconductors, we are using only one energy. That energy is photon energy. So, photon means quantized electromagnetic waves, whereas phonon means this is also energy, but the form is different. That form is this is quantized lattice vibrations. So, here that means here we are using extra energy. That means we are getting the more values. So, in order to conserve the momentum, for indirect band gap semiconductors, we need photon plus phonon energies. So, here we are getting the direct band gap values higher. So, indirect band gap means here same both the valence band maximum and the conduction band minimum will occur at the same k values. That means the momentum and energy is conserved, and here we are using the one energy. That energy is the photon energy, and we are having less band gap values. While coming to the indirect band gap semiconductors, here the maximum of the valence band and the minimum of the conduction band is not at the same k value. In order to conserve the momentum, we need extra energy. That energy we are going to call as the phonon. Both are energies, but this is the quantized electromagnetic wave, whereas this phonon is the quantized lattice wave. So, here if you see, it is having the higher band gap values. So, here for direct band gap only we are using for the direct conversion. What is this direct conversion pumping mechanism? This direct conversion pumping mechanism we are using in semiconductor lasers. So, here you need to remember that in semiconductor we have two types of charge carriers. One is electrons and second one is the holes. So, So here we are applying the electric energy to the direct band gap semiconductors. Direct band gap semiconductor, for example, gallium arsenide. So if we apply the electric energy to the direct band gap semiconductor, for example, gallium arsenide, what is going to happen? What happens? So what happens? For example, I am showing. This valence band, this conduction band, this band gap for gallium arsenide. And starting, the electrons are in the valence band. Okay, electrons are in the valence band. Okay, here. So this one is electron and this one is a hole. Okay. So after applying electrical energy to the atoms in the valence band, so what is going to happen? So the atoms absorb this energy. The atoms will absorb this energy, and here instead of atoms we can say electrons. The electrons absorb this energy. They started to move from valence band to conduction band. Here, these electrons we are going to call as a valence electron because they present in the valence band. So, while they are moving from valence band to conduction band, the state also changes. This one we are not calling this as a valence electron. Now, this one we are going to call as a conduction electron. Now, here, the absence of electron in valence band. The absence of electron in valence band we are going to call as in a hole, whereas the electron in conduction band, this is the conducting electron. Now this is the conducting electron. Now we have, that means here if you see here, electron hole pair is creating. Electron hole pair is creating. So if you see, at first all the electrons are in the valence band. After applying the electrical energy, the electrons absorb this energy and the electrons are moving from valence band to the conduction band. If the electrons are in valence band, we are going to call these electrons as the valence electrons. So if they are moving to the conduction band, these electrons we are going to call as a conducting electron. The absence of electron in valence band we are going to call as a hole. So now electron hole pair are creating. After some time, what is going to happen? The electron will come to the valence band. At the time of coming, the electron and hole will recombine at the junction. The electron and hole will recombine at the junction, and due to this recombination, they emit some radiation. There are two types of radiation. One is two types of recombination. One is radiative recombination and second one is the non-radiative recombination. So the electron and hole recombine at the junction. One is radiative recombination and second one is the non-radiative recombination. This non-radiative recombination means it is going to transfer into the heat energy. We need not the heat energy. If it is heat energy, the system is going to be what is going to happen? At some time it is going to stop working. So we need only optical energy. That means our light is going to be amplified with the help of this recombination. So at this, what is going to happen? Some recombination is happening. That recombination also radiative recombination. So this radiative recombination, they emit some energy, photon energy. The emitted photon energy are going to follow the properties of the lasers. The emitted photon energy is going to follow the properties of the laser. That's why we are going to get the stimulated emission. So here the electrical energy, that means here we are using the electrical energy for pumping the atoms. That means due to this, so here what is happening? So electrons and holes take place and the energy is directly converted into the light energy. Here this electrical energy is directly converted into the light energy. So this is one type of pumping, and last pumping is chemical pumping through some chemical reaction. This is very simple. Through some chemical reactions, the atoms will excite. Then population inversion state is going to be created. Here here hydrogen fluoride example, where we are using this chemical pumping, means we are using this chemical pumping in the hydrogen fluoride. Okay, so through some chemical reactions, okay, the atoms are going to be excited. With the help of this excited atom, we will create the population inverse state. After creating population inversion, we are getting the lasing action. For example, where we are using this type of chemical, hydrogen fluoride lasers. Okay, so next class we will continue types of laser. If you need, these are the references, you can also check it. Okay.